So the fourth concept to understand when going solar is the concept of the solar resource and the production factor. As we just described in the previous concept of power and energy, a solar panel, depending on where it is in the world, of course, and how sunny the location is and what the angle is to the sun, generally generate about the same watt hours as it is rated for. So a 400 watt hour panel, we said, would generate about 400 watt hours of energy under the sun. But of course, when you put together a full solar system with the panels and the inverters and the wiring and all that, there are some efficiency losses to take into account because there's friction in those wires. And also, depending on where you are in the world, the further away from the equator you are, and the closer to the poles you are, the less of a solar resource you will have, depending on your location. Whether you're in San Diego or Boston or Maine or Seattle or Florida, the average solar resource throughout the full year, an average of 365 days, actually does not vary all that much. It varies generally by plus or minus 20% of what that solar resource of the average location in the US. So if you have a 400, or let's just say 1 watt solar panel, which is tiny, but just to simplify it, I'm giving an example with 1 single watt solar panel. That single 1 watt solar panel will generally generate about 4 hours of energy per day. Why 4 hours? The sun is up generally 12 hours in the summertime, longer than 12 hours in the wintertime, shorter than 12 hours, but why 4 hours as opposed to 12 or 10? And the answer to that is because the sun doesn't really come directly onto the solar panel in the early hours of the day, from like 6 a.m. to 10 a.m. It's really low, and also the same in the evening time. And also there are clouds and rainy days and snowy days. So when you factor that all in, the average generally comes to about 4 hours, maybe 4.5 and 5 in most places. And in places like Hawaii or San Diego, you might get a little bit more than the 5 hours. And in really northern places and really rainy places and cloudy places like Seattle, you might get 3.5 hours of production. But so if you multiply this, let's say call it 4 hours per day times 365 days, you're going to get a number around 1,500. And that's generally a good number to estimate your solar production by. So every watt of solar panel is going to generate 1,500 watt hours of energy per year. So that's generally the math most solar technicians and solar salespeople and solar designers and engineers use when they are calculating the amount of solar or the amount of electricity that a solar system is going to generate. So that's generally the average production factor is somewhere around 1,500 watt hours per watt or kilowatt hours per kilowatt. So if we say an average solar system in the US is 6 kilowatts in size, that system is going to generate 6 times 1,500, 9,000 kilowatt hours per year. So divide that into 12, you'll get a number around 800 kilowatt hours per month, which is slightly under the 900 kilowatt hours of energy that a regular average home uses in the US. So that is the concept of solar resource and the production factor.